today's video, we're going to talk about a 521 start kit. This is the third start kit on the bar. We have good, better, best. We're going to talk about the difference between this start kit versus this start kit or this start kit. We're going to talk a little bit about these meters on which one should I use if I was trying to get in the industry, or if I've been in the industry for a while, in relation to inrush amps, and trying to figure out which start kit I should put in, utilizing the meter for the best results. These values, how they dictate what we do, and how customers can perceive that information accurately or inaccurately. So stay tuned. (521) compressor saver. All right, so we're going to go ahead and install this one. Very similar, except this coil takes a different voltage. Again, once we get to the smart board, we'll talk about those voltages and all that. And this one's nice because it gives you a nice little wiring diagram on where to hook everything up at. And so we're going to go ahead and get everything mounted, and we'll wire it up. This one also comes different colors. Some people prefer these because they get the best results. So we're going to go ahead and get our capacitor in there, and looks like everything's going to line up on the bracket, so I don't have to change my bracket out. Makes for a faster swap over. Sometimes you see these things is zip tied in here, and you got to do what you got to do, but always harp on a professional installation. Okay, so on these here, we're going to go off the diagram just to show you, since it was supplied. I'm going to put the potential relay back in there. Okay, potential relay is installed. Run capacitor is installed. See if I can't get a better bite on that. There we go. Full quarter turn there. Okay, it's been 3 minutes and 49 seconds. We're 217 over 265, so we're equalizing. All right, go ahead and unplug our board just so we can take advantage of that little time delay, so I can plug this back in and hold my meters up here. All right, so we have 3 wires. You got red, black, and you have yellow. All right, so we're going to look at the diagram here. And if you look at the diagram, it says we want to go to our stripe wire needs to go to hermetic. Hermetic will be the orange wire. We're going to go ahead and put it on the terminal. Make sure it's nice and tight. So now our hermetic's on there. The next one says the red wire from 1 will come up to the common side of the capacitor, which is in parallel with the run winding. Okay, so we're going to take this side up here, and we're going to connect it to the other side of the capacitor. Okay, as you can see, I'm using my clients to get my terminals on there, and that gives you the best fit connection, so that doesn't create any problems. Last wire is black. It's obviously going to the common side. It says it right there. And that's just coming over to the common side of my contactor. If you look up here, that'll be this black wire up top. Go ahead and there we go.
That's on there good. Try to pick up on it. It's nice and tight.
This start kit is a very common start component. It has a high microfarad start capacitor, and it offers a potential relay. That potential relay is to keep that start kit out of its circuit. We have one perspective where we actually install it at the unit. However, we like to talk about many different perspectives because there's a lot going on in that control panel. We have the defrost control board. We have contactors with all kinds of wires going on it. You have the wires coming into the unit. You have the low voltage wires as part of all that. Everything's just kind of zip tied and in the way. And so if we're trying to home in on where did I connect the wire on top of the capacitor, it's got all these other connections on it. You know, it's a very interesting perspective to try to learn on, especially in camera. So we want to take it to another perspective. And here at this table, we've got a contactor, a compressor, the meter of our choice, which is the SC640. I've got some wires that I've made up ends on where we can learn a little bit more about run capacitors and how to add to get a larger single capacitor or create a larger dual capacitor. I've got my alligator clips, and of course, I've got the start capacitor and potential relay, which the entire combination is called the kit. That's why they call it a start kit. This compressor here is a CR 53,000 BTU compressor. It's never seen the light of day outside the box. We just use it here in our training facility. So we're going to go ahead and utilize this to show you on the compressor windings, how do I tell where common run and start are? How do I wire up the start component and the capacitor and the contactor to this compressor, even though I don't have a fan motor here, just so for those that are curious on how to connect each wire in the circuit, what's in parallel, where is it in series, we can better understand that with less confusion. Once we're done with this, we're going to take to the smart board, so stay tuned for that. This is a compressor that is, if you're wondering, it doesn't matter what size capacitor I use for how to connect the wires, but if you are curious, it requires a 60 microfarad capacitor if we were to install this and put live power on it and pipe it in. So I have a dual capacitor here, which is 60 plus 5. I'm going to take it out of the box, and we're going to start with this one because I have the right size capacitor. Not that it matters, but because I have the right size capacitor, I don't have to start off with, you know, adding capacitors together. So we're just going to take the right size. It's a dual. We don't have a fan motor. We'll reserve the fan post for that in theory if we had that. I know I don't have the best camera angle. You know, it's hard to get all this in the perfect angle. So what we're going to do is we're going to take the camera after we wire this up, and we're going to pan it the area so you can have a bird's eye view. On my alligator clips, I have 4 different pairs of wires, 4 different colors. I have green, yellow, black, and red. We're going to stick with 3 colors. We're going to stick with a pair of yellow. We're going to stick with a pair of red. And a pair of black wires. We're not going to use the pair of greens. And the reason why I'm going to utilize these colors is because you find these colors very commonly inside the unit between common, run, and start. And so I think they're a great combination of colors to utilize for this learning perspective. We're going to go ahead and first show you the start component. And as you can see, it's got a bunch of wires on it. Now there are 3 wires on this start component. This is called the 521 because you have 3 terminals on your potential relay, 5, 2, and 1. And so what they have done is they've taken one of those terminals and they pre-wired it to the start capacitor. And so I have a red wire that I have to wire up. I have a black wire coming off my potential relay that I have to wire up. And then I have my yellow striped with red and blue, okay, coming off my potential relay that I have to wire up. So these are the 3 wires that I have to wire up. Now the other videos we've released, we showed you where there's only 2 wires to wire up. Here we have 3. So we're going to talk about that in good detail. First, we're going to go ahead and pre-wire the run capacitor, and then we'll start energizing the theory of what comes off of T1 and T2. We're we're going to pretend that there's L1 and L2 already on here. So we're going to go ahead and take the yellow wire coming off the potential relay. That yellow wire is coming off of terminal number 2 of the potential relay, and it is striped with red and blue. This is going to go to our hermetic post of our capacitor. All right, we're going to go ahead and take the black wire and our red wire, and we're going to wire them next. Okay, the black wire typically is going to go to your contactor. You want to go to the top side of the contactor. That way it's not going to get any voltage until the contactor pulls in. So I'm going to say that the from your angle, the left-hand side of the contactor will be the L1, and the right side of the contactor from your angle will be L2. So I'm going to say that L1 is going to go to common on the compressor, and if that's the case, then I'm going to land on the top side of this contactor for that. Now I have the red wire. I have a couple of choices here. So I'm going to go ahead and show you one way of doing it is I can just come to the top side of my contactor for L2. And theoretically I'm done at that point. Just if I wanted to know where do I land my wires at for the start kit. There is a second way of doing this. I'm going to go ahead and unhook it. I can come over to my common post of my run capacitor. And now if you wanted to just see where do I make this connection, I don't need to know the rest of this. Simply we've done that for you. I'm going to hold it up. All right, so you have hermetic, which is the yellow with red and blue stripe. We have red on common, which is coming over to our start capacitor, okay? And then our potential relay has a black wire coming off of it, which is on terminal number 5, and it should be coming over to the side of your contactor that will feed the common to your compressor, okay? And now we're going to go ahead and disconnect this, and we're going to go through this the way I like to go through it, which is a lot more detailed. I'm going to go ahead and move my start component over here, and we want to go ahead and let's check out that capacitor, and let's see if we even have the proper microfarads on it. So we're going to take our meter, we're going to come over here to MFD for microfarads, and we're going to take our 2 leads, and we're going to come over between common and Herm, and we should be reading 60 microfarads, and I read 60.6. Okay, now between common and fan, I should read 5, because that's what the label suggests, and I read 5. So I know I have a good capacitor. So starting off, we want to know that out of the box, do I have the proper value? And the answer is yes. So we're just going to set that back over there, so when we go to begin to wire that up, we didn't miss any proper steps. But what if I don't know what my terminals are on my compressor? I would have to remove this cover, and I would have to ohm out my pair of windings. Now there's 3 windings here, common, run, and start, but I need to know what is my combination between any 2. Well, because there's 3, I'm also going to have 3 combinations. So we're going to take the combination of the top 2, and we're going to see what that ohms out. And we're going to go ahead and switch our meter on ohms, and we're going to look and see what that number is. And it says 2.0. I'm going to go ahead and leave 1 lead on the top left. I'm going to come down to the bottom, and I read 0.4. Okay, so this pair is 0.4. Across the top pair, I have 2. Now I need to know from the top right to the bottom, what would that pair bring me? And it says 2.4. So all of that adds up to the highest value, the highest pair. So I have 2.4, and then 2.4. So in every case, when I use the top right, I'm getting my highest value. So that's going to suggest that that is my start winding. Okay, and then where I'm getting my lowest, that's going to be my common. Well, every time I went over here to my far left terminal, I got 0.4 in that combination, right? So I got 2 going this way and 0.4 going that way. And so right here, that will be common. And then down here, I'm actually reading between start to common, and then this would obviously be run. I'm reading this combination, so I'm adding this to this, so that would suggest that that would be my run winding. So start on the top right, bottom will be run, and then the top left, that'll be common. I'm going to go ahead and wire this up to my capacitor and to my contactor. We're going to use alligator clips to do this. So if I said that that left side of my contactor was common, we're going to say L1, okay, L1, L2, then I'm going to run this over to my common post to my compressor. Now this video is about how to wire a start capacitor. How do I wire a start kit? How do we do that? Let me go ahead and turn my meter off too, by the way. Always good practice to not kill your battery. And you know what? I'm going to go ahead and just unplug these leads so it's less confusion, because one's black and one's red, and I know we're looking at this thing and I want to make this as easy for you as possible. I have one extra black wire. We're not going to need that, so we're going to go ahead and take that and just put it over here in our pile. Next, we're going to use red. We find red and black quite a bit between our commons and our runs for our compressors. So our compressor has to have 240 volts, so we're going to go ahead and add that second leg. That second leg will come down to our run winding, which we know is our bottom terminal here because we owned it out. And so now we, in theory, have got our 230, 240 volts here, but we're missing our start leg. And that start leg is going to be fed off of the hermetic post of our capacitor, which will be in series with the start capacitor as long as the potential relay is in the closed position, which we're going to talk about in better detail when we get to the smart board. Okay, so now we're not done. We're going to have to wire up our start kit now. And now, how I started off in the beginning of the video, I said we're going to take terminal 5, which is black, and we're going to go ahead and wire that up to our contactor, which is going to common on the compressor. So this is feeding us one leg of power, which would be leg 1, the first leg. We'll call that L1. Okay, and we have terminal 2, which is yellow with red and blue stripe. That is going to come over to our hermetic post of our run capacitor. Okay, we have our red wire, which we can put it in one of two locations. I can either take it to the same side of my top of my contactor that is going to run, so I can feed it a second leg of power, because this coil receives 2 legs for the coil to be energized instead of 1 leg like the last one. So this is a 230 volt coil. I can wire it to common over here on my run capacitor as well. Now, I'm going to wire it to my run capacitor. Typically in the field, that's what you're going to do. It's a little bit easier. But I also need to feed my run capacitor that same leg of power back to it. So I'm going to come over here and I'm going to run an alligator clip off of T2, which would be leg 2. And that's going to come over here to common. And bear with me, I'll give you a bird's eye view of this. That's going to come over to common on my capacitor. Okay, and so this is successfully wired up with the exception of a start winding to my compressor, which is going to come off of my hermetic side of my run capacitor. And I'm using yellow to keep this a little bit easier to understand. And this is going to come over to our start winding to our compressor. Okay, and so everything's on there. I'm going to go ahead and take the camera and I'm going to show you what this looks like bird's eye view. Let's first look at our compressor here. On the compressor, we can see we have all 3 of our windings with different colors on them. We have our start winding, which is yellow, our run winding, which is red, and our common winding, which is black. And we can see where they go to. The red's going back to the L2 side of the contactor. The black, the common, is running over to the L1 side of the contactor. And our yellow, the start, is coming all the way around over to the hermetic side of our run capacitor. I'm going to go ahead and show you now a bird's eye view. If you look at our contactor, all we have coming off of it is terminal 5 for our potential relay. And then we have our alligator clip, black alligator clip, which is feeding the common side of our compressor. We have on the L2 side a red alligator clip, which is coming up and is feeding the top portion of our run capacitor, the C, which is common for the capacitor. And as you can see, we have a red wire coming off of it additionally, which is coming all the way over to the start component. I'm going to go ahead and point to it right there. This is the red wire that I'm talking about. If you look at the yellow wire with red and blue stripes, it's coming off of our hermetic side of our run capacitor, and it's feeding the potential relay, which is terminal 2. I know it looks like it's coming over to the start kit, but it's not. It's just the way the wire is curved. And so you can see our potential relay there. So there's a bird's eye view. This is all we have to do, and this is theoretically wired up, you know, by the book. I'm gonna go ahead and set the camera back down. Get it positioned back where we can see everything. There we go. Get it back a little bit more. I think everything's in view now. Okay, so taking this a step further, we're going to put our leads back on the meter. And we're going to work out a couple of problems that we typically see in the field where capacitors are used all day long, and we get into situations where we don't have the right size because we've used everything in our inventory that was a common size. So we get into situations to where we have to improvise a little bit. I'm just unhooking the run capacitor right now because we're no longer going to be utilizing this run capacitor. Say this run capacitor was bad, and go ahead and put it back in the box. And say I need a 60 microfarad run capacitor, but on my inventory, all I have is a 55 plus 5 dual capacitor, but I need a 60 microfarad capacitor for my compressor. Well, I wouldn't take the 55 plus 5 and only use the 55. I would take the 55 plus 5 and I would make a single larger capacitor. So I'm going to show you how to do that. We're going to go ahead and take the capacitor out of the box, set it on the table. I'm going to show you that it's a 55 plus 5. Okay. I'm going to go ahead and check the microfarads on it because we don't want to just take the value that the box suggests and say, okay, it's brand new. It's what it's going to say. We're going to put our meter on MFD. We're going to check the microfarads between common and fan. Now the box said I should have 5. Here I have 5. Between common and Herm, it said I should have 55. And I'm reading 55. So what we're going to do is we're going to take a jumper that I've made up, and we're going to go ahead and put it on the capacitor, and we're going to jump out 2 posts. We're going to jump the hermetic post out with the fan post, and I'll hold it up so you can see it. This is all I've done, is I've jumped out the hermetic to the fan, okay? And now I'm going to go ahead and go where I used to read 5 between fan and common. And now I should read 60. And I read 60. I'm going to come over between common and Herm, where I used to read 55, and I read 60. So now I know I have successfully added both post, hermetic and fan, to make one large single capacitor. Now we're going to go ahead and put it in circuit. So we know the red wire, which is coming off our run winding, L2, is going to energize common, top side of our capacitor. And the red wire coming off of our start capacitor on our 5-to-1, it's also going to come off of common because we have to feed it L2. Now remember, I can also take it over to here. I think it's going to be easier for you to just take it to the capacitor, so we'll go ahead and do it that way. We have the terminal 2, I'll put that back, terminal 2, and our start winding that have to be wired up now. We're going to take terminal 2, which is the yellow wire with red and blue stripes. We're going to go ahead and connect it to our hermetic post. So I'm in parallel at this point, but the moment that I connect my start winding back up to Herm, it's in series as long as the potential relay is in the closed position. So we're going to come over here where it fell off of our terminal. Obviously this is not going to happen in the field because things are actually screwed to these posts. We're not using alligator clips. There we go. And again, I'm going to go ahead and take off my leads just to take these colors away so we don't get any confusion. Go ahead and turn our meter off. And I'll give you a bird's eye view. Again, we have our compressor. On our compressor, we have black for common, red for run, yellow for start. You can see our yellow is wired back to our hermetic post on our capacitor. You can see that our red, our run, comes all the way around and is wired to L2 side of our contactor, which is also feeding the common post to the capacitor, okay? And then you can see our black wire, our common wire, that alligator clip comes over here to L1, which also off of L1, we're coming around with the other black wire to our potential relay, which is on terminal number 5, and I'll get a little bit closer so you can see that a little bit better. Here's a better bird's eye view. Got our capacitor jumped out. Everything's wired up. Pretty simple stuff here. And in that theory, we would be good. So we're going to go ahead and try another capacitor in the event that we did not have a 55+5 dual. We're going to go ahead and unhook our run capacitor. I'm going to take my jumper off because we don't need that anymore. We're going to take this 55+5, we're going to go ahead and put it back in the box. Say all I had was a 45+5 and a 10. Say that's all I've got. Can I make one large single capacitor out of a small single and a medium-sized dual? Well, the answer is yes. So if we need 60 microfarads, how do we get that out of a 10 and a 45+5? So first, we're going to go ahead and take them out of the box, and we're going to see what those values are. Just because the box suggests that these values are there doesn't mean that we can trust that. So we have to verify. We owe that to ourselves. We owe it to the equipment, and we owe it to our customer. I said it in that order because if you're DIY, you don't have the customer. So we're going to go ahead and come over here to MFD, and let's go ahead and check this small capacitor where it said 10. What are we getting? Get my leads on there just right. There we go. And it says 9.97. We're going to come over here to common and hermetic, and it says 44.5, and between common and fan we have 4.9. So we're going to say 5, 45, and 10. So we're going to go ahead and add these together, and I'm going to need a couple of different wires. First, I'm going to go ahead and make this one a 50, okay, by taking my fan and my hermetic. kind of like what we just did. Let's go ahead and test out the microfarads now. Between common and where we used to read fan at 5, we now say 49.5, so we're going to call that 50. Between common and Herm, we read 49.5, so we're going to call that 50. So now we're going to go ahead and add the other 10 to it. I'm going to come off of hermetic. I'm going to come to one side of my capacitor. Now that doesn't complete it because I have to put both commons in series to make them one. I'm going to use a different color just so we don't get confused on what side is what. And I'm going to go ahead and come over here to common and put it on both sides of my capacitor. I'm going to hold it up bird's eye so you can see. And now we're going to come over here where we used to read 10, and we should read 60 now. And we read 59.9, so we'll call that 60. And so now we know we have successfully added that up properly, because if we didn't, we wouldn't have reached 60. So now it's safe to go ahead and put this in circuit. So we're going to come over here and we're going to wire up, okay, where common's going to be, okay, to our red wire, which is coming off of our start kit, which is in series with terminal number 1. And we're going to put that on common to our capacitor. We're going to go ahead and take L2, which is coming off of our run winding, right? It's feeding power to that. We're going to put it on common here of our capacitor. And then we have to connect our start circuit up to hermetic, and we have to connect our potential relay, which is terminal 2, over to our capacitor as well. Now I'm going to come over here and I'm going to push this down onto hermetic. Okay, so now the start capacitor is in circuit. My start winding needs to be connected. So I have options here. Every one of these wires that are color coded white is part of my hermetic now, because we've added them all together. So I can come to any post that has white on it and put my start winding in circuit there. I am running out of space where it's allowing me to do that without having an additional connector. They have female to double male connectors. Typically they're brass color. You can buy those, stock those on your truck. That'll help you in this situation, because where you typically what you want to do here typically is you want to go to the post that always read the highest value, because as these capacitors weaken, I want to be left with, you know, if I shorted out the 5 side and I didn't short out the 45 side, well, I would rather have my start winding hooked to my 45 side, right? Same thing if my 10 microfarad shorted out, I've lost 60 and back to 50. So if I was hooked over here to my 10, that's not good either. Now that doesn't mean that my 45 can't short out, right? If that's the case, then we lost a third leg of power. And even though there's not a third leg of electricity here, the capacitor is what keeps this thing with polarity. So we lose that polarity once we lose our hermetic. So, and these things are thermally protected. They'll just overheat and it'll open and not allow power on the common terminal to be energized through the windings. And so they're thermally protected for that reason, right? But I'm gonna, for the purpose of this video, I'm gonna wire this up to a spare post that I do have. Which is on my 10 microfarad side, even though that on the 10 side we are reading 60 microfarads. I'm gonna give you a bird's eye view again. Before I do that, I'm gonna go ahead and take off my leads. Get that black and red out of there so we don't confuse ourselves. Turn the meter off. We'll come back over again to our compressor where we have common, run and start, black, red, and yellow. bird's eye view of our contactor here. Nothing's changed. Nothing changed on the potential relay. Nothing changed on the start capacitor. All we've done is we've taken two capacitors. You've seen how we jumped them out, okay? And we have now our start winding now coming over here to our 10 microfarad capacitor, even though it's reading 60, because we've added it to this capacitor. So this capacitor plus this capacitor now equals 60 total. However, we did not have enough terminals here to add a fourth conductor. We only have 3 conductors on it. We have 2 of them being used up because we had to jump out our dual capacitor to create 50, and we had the other one over here to our 10 where we've had to add that extra 10 to it. So we ran out. We do not have a fourth terminal on there, so we used yellow, our start winding, or over to our smallest hermetic post for the 10. In the field, we would not want to do that. We would want to come over here and just add an additional one. Now, there is, if you don't have any connectors, there is one other way to do that, and I'm going to show you real quick. If I was stuck with what I had on the truck and I did not have that jumper, then what I would do is I would take, because I know my start kit is only in circuit in the very beginning, which at the smart board we'll cover that in detail. It's out of circuit when I'm running. That's why it's called a start kit. It's not a run kit, it's a start kit. And so I would take this and I would take my start winding. I would take my start winding and leave it on my highest post of my run capacitor, which would be hermetic here. And I would take this, since it's only in circuit in the very beginning, so if my capacitor went bad, not a big deal. And I would put that on the smallest hermetic post, which is the 10 side, even though in conjunction it reads 60. I'm gonna give you a bird's eye view of that. So if I was in the field and I was stuck with what I had, like here I have in the lab only what I'm working with, this is the way that I would wire it up. I have my yellow wire for my start winding coming over here to my highest hermetic post all by itself, and I have my start, my potential relay, which is terminal 2, which is putting my start kit circuit at this point. And since it's only in circuit in the very beginning, if this capacitor went bad, it's okay, because I have bigger problems anyways, because I'm not running on a 60 microfarad anymore. I'm now running on 50 microfarads, and I need to replace that run capacitor anyways. If you are going back out to the house, or if you have the opportunity to change that capacitor to the right capacitor, even though in theory it's right, there's not a lot of space in these corner panels, especially when you start adding start kits and you have to start adding capacitors. It's a better practice to always come back and clean it up a little bit and put one capacitor in. Just a little FYI there, a little tip and trick of the trade. This is pretty much all we need to cover on this perspective. Some people, they learn better at this perspective where we're just making connections. Now we're going to take it to the smart board where we talk about good, better, best, what meter, what start kit, and then we're going to wire this up and talk more about that potential relay and how that makes these kickstarts, these start kits, a little bit more special. So stay tuned. Okay, so we're now at the smart board. We've gone over 2 perspectives. We had a perspective where we were talking about the start kit outside at a condenser unit where we installed the 5-to-1. Wasn't a whole lot to go over there, just kind of plug and play, maybe a little bit of mounting, whatnot. So we wanted to cover another perspective to where, what if we just took some alligator clips and we wired that 5-to-1 start component up to a run capacitor, contactor, start winding, common winding, and a run winding for the compressor. And if we didn't know which winding was which, how do we even determine what's common, what's run, and what's start? In that, it was interesting. We were able to see that common had the lowest value as a pair, run had the middle value, and start had the highest value. And that's how we were able to determine that. A lot of these compressors are already labeled, and that's good to go. Getting into it, behind me I have a picture of three start components and 3 meters. On these start components, we covered in one video the Super Boost, another video the Kickstart or TO5. The only difference between those two is literally one's for 1.5 to 3 ton compressor, one is for a 3.5 to 5 ton. You have the 5 to 1 also, which has different microfarads on their start capacitors. And at the end of it, there is a difference between these two when it comes to the potential relay. These squares here are the potential relays, and their jobs are to keep the start kit from being in circuit when the compressor is running. So they're only there for that initial, hey, I'm coming on, you know, lower that inrush amp or unlock that compressor so it can run, but it cannot stay there. And it's very simple, because if you look at a run capacitor, you know, standard run capacitor is a 45. In our situation, we were dealing with a 60. Doesn't really matter for the purpose of this video, but that's what should be in the circuit all the time to keep the compressor running. So the start component is a capacitor on a larger scale that is only in circuit in the very beginning. And what makes it special is it has a potential relay to ensure that as long as this relay has coil voltage, that the contact is now open, keeping the start kit from adding more microfarads to that start winding. If that was closed or wired wrong, then I would have, say, 325 microfarads plus the 60 microfarads on the run. I can't have 385 microfarads. This compressor is not going to be able to handle that kind of energy. So we need potential relays, and so it's important to understand those potential relays. When we get to our how to wire this up, we're going to wire the potential relay and we're going to wire that start kit as if we pulled the wires off and we didn't have them. How does that work? And there's instructions. There's obviously many things that you can ascertain online too, but the purpose of this video is to try to better understand and learn so we don't forget. And so we cover many different perspectives. This third perspective on the smart board is to, you know, how do I wire that if I just looked at a diagram, and if you can make sense of it, I won't forget it. And that's typically how most of us hands-on work. It's not always about plug and play, because we can forget things if it's not a daily practice. We have the 3 meters, the good, better, best, and we measure inrush amps to find out if we need a start component. Those inrush amps aren't always going to yield the same results when we use different meters. So if I said that I wanted to take a Super Boost start kit and compare it to a KS1 or a 5 to 1 kickstart, one potential relay meaning 230 volt coil, another potential relay that could need 120 volt for its coil, you know, how do I know which one's better unless I, you know, exercise different meters and see what those values are? When you have enough experience and you have enough knowledge of this, you start going to what's going to give us the best results. In this situation, we have labeled the 5 to 1 better than the KS1. Now, even on the price range, you know, this is on the lower end of the spectrum price-wise. So as we start to pick up from good to best, we wind up spending more money on these start components as well. When we start getting into the meters, it's the same thing. Like, this might be $350 to $400 for this meter, depending on where you bought it at, versus this meter, which could be less than half of that cost. And then over here, we can spend even less than that. And so you can't say that, well, this meter read an inrush amp of, say, 60, and that's it. Because if I compared it to maybe this meter over here, the SC640, maybe I read 90. So if one meter read 90 amps startup, and this meter read 60 amps startup, whether you're DIY, the customer looking at your technician doing that, or as a technician in the field, you're going to look at that and go, well, which one should I buy? Which one is accurate? Which one is better? Is this 60 the right value? Is the 90 the right value? Well, let's look at a couple things. If you took a thermostat that cost $2, not a thermostat, but a thermometer that cost $2, and you said, hey, my temperature is 75 degrees in this room, and then you took out a thermometer out of your tool bag that cost you, say, $45, and you said, well, I'm not reading 40, or let's say you're 75 degrees in that room on a $2 stick, and the $45 stick read, say 77 degrees. Which one would you trust? Probably the one you spent more money on, right? It's a better tool. It's more accurate. And so when we start spending less money on tools, and we start spending less money on start components, and we start spending less money for service technicians, your buddy's doing it for you, and he's drinking a beer or something like that, and he just came over on a Saturday and he doesn't really have a whole lot of time, what kind of value are you really getting? What kind of value are you going to trust? And so there's a lot that goes into this trade on many levels, not just of refrigeration, commercial, industrial, residential. It's not just that. It's not you do airflow, you're a technician. It's all the way down to what tool are you using that is supposed to give me the same reading, used for the same job, within the same trade, same industry, as this tool. So customer can, if you were a cook, what's a better frying pan. You're going to be looking at all kinds of qualities, like, hey, is food going to stick to it? Is food not going to stick to it? Well, that means a lot, not because you're washing a dish, but because you're cooking on it, right? Which one gathers heat evenly all over it? Which pan is going to hold up long term? Which pan aesthetically looks better? There's lots that go into that. As far as knives go, people have a preference on that. What knife is going to hold up better than another knife? What pair of gauges should I use? What kind of hoses should I use? Should I use low loss fittings, no fittings at all? Do I use analog gauges? Do I use digital gauges? And there's so much that goes into our industry. And we haven't covered all of that, but we will in all these videos. Right now we're covering just taking an inrush amp, just a start amp, not because we think that, it's a necessity to, sell a start component, but we think it's a necessity to understand what is the highest value that I can possibly read using the most expensive meter on the market that is most sensitive, so I can leave that unit in its most reliable state. That's what it boils down to. So if you're looking for longevity, if you're looking for, the best results, performance, guarantee, just that stability, that reliability, then you have to start looking at what tools are you using? What level of education do you have? Who on your team is helping that education be passed on to those junior technicians? And what component, because they all say they do the same job, which one do I use? So we have a very interesting video that we'll be releasing soon where we're actually comparing all three of these and different combinations of the meters at the exact same time, so we can actually see what those values are. So stay tuned to that video when it comes out. As far as this video, we want to know, how do we take this 5-to-1, this one start component, and how do we wire it up? So we're going to get right into it. Now I have what we can call a condenser fan motor. We have our compressor. We have our dual capacitor. We now have a bird's eye view where we can see our common, hermetic, and fan post. We have a bird's eye view of our start capacitor where it has a bleed resistor on it. We have a bird's eye view of our potential relay where we can see all of our terminals, where the contacts are, and where the coil is. We have a picture of a 2-pole contactor, and we have our L1 and our L2 lugs. And so we're, like all of our other videos, if you've been following, we're going to go ahead and wire this up step by step, and then we're going to talk about this potential relay and how this potential relay allows this to not be in circuit when it's running. So the first thing we're going to do is we're going to go ahead and put L1 and L2 on the contactor. So we're going to go ahead and energize L2 and L1. And now the contactor being in the open position, there's no power here. I didn't want to put a one pole up here or anything like that where there was always going to be power, because I really want you to understand this and not further complicate it. There's a lot of confusion when we have start kits being added, especially when there's no wires on it. Everybody's just kind of lost. I've seen some cases to where these don't even get used, that they've snatched wires off of it. And what I'm talking about is if somebody needed to, you know, have a wire where I've made up a handful of wires here with connectors on each end, you know, somebody could simply just take a wire, you know, off of the potential relay and say, hey, I'm going to use this wire now. Okay, well now this potential relay is missing a wire on it, and the package is gone and there's no instructions, and say all that was the case, but I had a perfectly good potential relay never used and a perfectly good start capacitor never used, and somebody just removed all the wires on it. Technicians do this stuff because they've got to get through their day. All right, and sometimes things just don't go back. And so if you're in a situation where you need a start kit, you have one, but you don't have the wires, you want to know how to wire this up. I'm going to go ahead and pre-wire what's already there, okay? And what I'm talking about is, when I say pre-wire, the 5-to-1 has 3 wires that are not hooked up on one end, okay? The black, the red, and the yellow with the red and blue stripe. And so the only thing that's wired to the potential relay here is this red wire, which is coming off of terminal 1 over to the start kit. And so that's the only thing that's actually pre-wired, because the other 3 wires, you have to land those. So I'm going to go ahead and wire up the one wire that is wired for you. The rest of those wires, you need to put those somewhere. So we have a wire coming out of here. I have a wire coming out of here, and I'm going to go ahead and switch my color up a little bit. I have a wire coming out of here. So 5, you have to land it somewhere. 2, you have to land it somewhere, and one side of your start capacitor, you have to land it. So we're going to cover where those get landed. So we're already beginning in the right direction. I'm going to go ahead and just continue with red. Let me go back to black. All right, I'm going to go ahead and continue with red, which will be the top side of my contactor. I'm just going to use L2 because that's red also, where that would go. 1, we know our compressor, it needs a leg of power. So we're going to come over here and we're going to run a leg of power up to our run winding of our compressor. Okay. And our other leg, we already know that's going to go to our common winding to our capacitor. We also have to run a wire to our condenser fan motor because it's also now part of the diagram, whereas before we didn't. So I'm going to go ahead and run L2 up to our run winding over there. Okay. And so now everything on L2 is complete, with the exception of I have not landed anything up here over to my contactor or run capacitor. And we're going to save this for last. All right, so we're going to go ahead and wire everything else up first. I'm going to go ahead and take L1. We're going to go ahead and wire it up now. I'm going to go ahead and take L1 and I'm going to wire up my fan motor. So now I have 240 volts on my fan motor. I'm missing the start leg, but I have 240 volts there. I'm going to go ahead and run a wire over to my compressor common terminal. I'm going to switch the color up here so we can see it. There we go. And now we have 240 volts on our compressor. However, there's nothing on our start winding. So we're going to go ahead and now wire up our start winding, which we're going to use yellow. Everybody's familiar with that color in this color scheme. And we're just going to come out of our hermetic on our run capacitor, and we're just going to run it over here to our start winding. And then we're going to come over here with, I'm going to use purple just because we're used to seeing purple on our fan terminal to our start winding of our compressor. Okay, I'm sorry, our fan motor. So this is traditionally how you see it. This is already done. We have not added the start component to it. We're now going to add that start component to it. All right, so on the potential relay, we have 5 and 2. They are color coded, so you can see black's pretty much going to go to black, yellow's going to go to yellow, and on our start capacitor, red's going to pretty much go to red. So how we're going to do this is we're going to take our yellow off of 2, and we're going to run it down to hermetic, tie it in here. Okay, so they're in parallel at this point, but because this is closed, it's in series with the start winding. Even if the contactor is in the open position, it can still be in series even if it's doing nothing. It's just not doing anything. 5 needs to come over and get coil voltage. Okay, 2 is actually getting coil voltage. 5 and 2 is coil, 2 and 1 is contact. Okay, they're actually taking the same terminal for 2 and they're making it one side of my coil and one side of my contacts. So 2 is a little bit busy. It's got more going on there. So 2 is actually getting coil voltage through the run capacitor on common, which in this diagram is L2. So if this is L2 here, if I'm L2 here on common, then I'm actually L2 here. And if I'm L2 here, I'm also L2 here, and I'm also L2 here. So that's L2, then this is L2. And so now we're going to go ahead and go to black, and I'm going to say that black is going to come down. I'm going to take the shortcut and bring it down to my contactor, which we know is L1. And if that's L1, then we know this is L1. So now we have L1 and L2, so we have coil. So now I have L2 present all the way through on terminal 1, okay? So that means L2 is here, L2 is here, L2 is here, and now L2 is here, and that is going to simply come over here to my start capacitor, and that is going to come back over here, which you can see L2. And so that's all on that L2 leg. So L2, like I showed you in all the other videos, one leg is always doing a lot. It's always doing a lot. Common is just going to be L1. Okay, so L2 is doing a lot. So I'm going to erase this, and I'm going to do it one more time now that we've done explain that. And we're going to probably erase this a couple of times and continue to talk about it because we want to make sure it's well understood. Okay, so we're going to do this one more time. We're going to go ahead and say that L2 comes into the contactor. L1 comes into the contactor. Okay. L1 leaves the contactor, comes over to the compressor, ties into common, comes off the contactor, ties into common again. So now our condenser fan motor and our compressor now have L1. If I said L2, I apologize, I meant L1. L1 is now all the way through, tied to common, L1 again, all the way through to the condenser fan motor. And then 5 needs to also have L1 on it. So we're going to take 5 and we're going to come down and we're going to wire it. So take a second, look at that. L1 all the way through is done. Okay. Now we're going to go ahead and erase this. And now we're going to talk about just L2. We put common back over there. Oops. Okay, didn't mean to erase that. All right, we have red now. So let's talk about L2, the very top post. We're going to now say that L2, we know it's got to feed our common post of our capacitor. We know it's going to come around. It's going to feed the run winding of our compressor. We know it's got to come around and feed, draw that a little bit better, it's got to come around and feed our run winding of our condenser fan motor. And one is already wired to our start kit, okay, our potential relay and our capacitor. That's a kit, it's a combination, okay. And coming out of here, this has got to come down to common. Now I can come here, or I can come out of here and I can land it there. So take that in for a second, and I'll go ahead and take that last step out, because typically what you're going to do, let me draw that a little bit better. What you're going to do is you're going to land it here on top of your capacitor. Okay, so now everything on L2 is complete. So I have, rewind it, you'll see L1, and then where we are right now, we have L2. Okay, we're going to go ahead and erase all this. And now we're going to talk about our hermetic winding, our start winding. All right, same thing, hermetic post and our start winding. We're going to come off of terminal 2. We're going to bring it down to hermetic, out of hermetic, and that's going to come to start. We're going to change the color up to purple, and over here on our dual capacitor fan, we'll run over to start on our condenser fan motor. Let me put a little arrow here so we can see that input. Okay, so there's everything for the start windings. So we covered our commons, we covered our runs, and we covered our start. Okay. That's kind of breaking this down in sections. Now, there is one thing that I am missing here. To put this in circuit, this has to obviously be tied in, and this has to obviously be tied into here, and obviously L2 would be tied into this point. So that would actually complete that portion of circuit. Now notice I didn't take L2 and run to my run winding on my fan motor or compressor. Okay, so take that in for a second. Okay. And now to complete that, okay, we're going to come over here and we're going to run our run winding to our compressor and our run winding to our fan motor. Okay, and the only thing that we're missing, okay, is our common to our compressor, or common to our fan, and terminal 5 for our coil on our potential relay. So we're going to go ahead and take 5, we're going to run it down, tie it into L1, so we now have 2 legs of power on that relay. We're going to come out of here, we're going to run it up to common on the condenser fan motor, and we're going to come out of here and we're going to come over to our compressor, and we are going to run a leg of power up to the common on our compressor. Everything is 100% now. We are 100%. Now we need to cover a couple of things. If we had to add capacitors, we want to put that in here so we can understand how that works. Before I do that, let's go over a little bit on this potential relay. So the potential relay, when the contactor is in the open position, see this contactor, it has no wires on it, it's in the open position, right? I can push it in. All right, so there's no power here. There might be power on the bottom side if we wired L1 and L2, but because there's no coil voltage, the contactor is in an open position. Because it's in the open position, there's no power up here on the top side between T1 and T2. So I might be reading L1 and L2 here, but without common and Y, my contactor's open. Therefore, I don't have any power on this side. In theory, we do, but in this position, if you look here between 1 and 2, it's closed. Well, when 1 and 2 are closed, that means that this start capacitor right here, this start capacitor is literally in circuit with the start winding, okay? So we are in circuit, okay, through, all right, this set of contacts, which is normally closed. So let's go ahead and write that up here. Use black. We have 1, we have 2. That would represent open. If you look here, we're closed. So we're going to put an NC there for normally closed. All right, now we have 5, okay? And 5 is the coil. Now, all I did was I just kind of rotated around. So, you know, I'll go ahead and write that a little bit easier. All right, so I have 5, 2, 1. Between here and here, I have a set of contacts. Between here and here, I have a coil. Now this coil needs L1, it needs L1, and it needs L2. That's what this coil needs, okay, for this to be open. So when I am missing these legs of power, then the state that this coil is actually in is a closed position. So I'm going to write NC here. So what that means is this start capacitor is in circuit with this start winding the entire time there is no coil voltage, or the contactor is in the open position. In other words, the unit's off, it's not running. So when it's not running, the start capacitor is putting 325 microfarads on the start winding, which theoretically it can't, because there's no energy being released on the start capacitor if there's no energy being supplied to the start capacitor. So, you know, 2, all right, is over at the hermetic side of our run capacitor in parallel, right? So let's just follow the diagram. We have L2 supplying power to common, and through common, it's going through the compressor, and out of common, it's coming up here and it's supplying power to our start capacitor. So I'm going to say this is a input, okay, and through here, this is a output, okay, even though here this is an input, but it's still an input because the way the electricity flows, it's all part of the circuit. It's why it's called, it's in series, okay? So your connections are in parallel, but the whole thing's in series. So let's look at that a little bit further. We take this relay and we open it up, it naturally drops this out of circuit, and it's open anytime there's two legs of power present on the coil. Well, the coil is getting L2 from this point, and it's getting L1 at this point anytime the contactor is calling. So the moment the contactor pulls in, the relay is already closed. So the moment the contactor pulls in, the relay is opening. So it's only in circuit for a fraction of a second, which is why they call it a kickstart. So it's kind of like, it's not kicking it, it's kind of like the foot's already on it and it's releasing, right? So that in that split second, it's got standby energy that is taking out of circuit, right? Which is giving this a boost of that start capacitor's energy and leaving the run capacitor in circuit to keep it running. So that reduces that inrush amps. It winds up taking a lot of load off of that electrical winding, that start winding, which will prolong the life and health of that compressor. And so we get into situations where these have to be there to unlock them, but there's also situations where we just want to reduce inrush amps to either take that load and reduce it, adding value, longevity to the compressor. Also, we want to make sure that when we do that, we're conserving more energy on startup, so your electric bill is lower, you're paying less money for operation. Theoretically, they pay for themselves very quickly. And on that note, you know, you can't really say that it shouldn't be in there until it's locked up. You can almost say like, hey, why don't they just come that way? And they're not going to come that way. And at the end of the day, you can always add one to it and it would never hurt. There's always a benefit to having one of these things there. And when they have a potential relay on them, they're not staying in circuit like Super Boost do for a few seconds. And then once they warm up, they open up and they allow that to drop out of circuit. These are immediately out of circuit, which makes these better. Now, what makes the 5-to-1 better than the KS1 or the TO5? Well, the heavier duty your relay, the better the part. When you start getting into coils that require more voltage for them to operate, you're getting into bigger and better things. So when you wind up looking at that just from that one point of view, it's like, why not? If the difference in price is $10 or $15, just go for it. You know, it's not like there's a huge difference in cost. Now, we have a video where we put soft starts in comparison with these. And to let you know that a hard start and a soft start are two different items. They're on two different ends of the spectrum on value and results. And we have a video that we're going to be releasing on soft starts where we're actually using the soft start to compare against the hard starts. And it's an enormous difference. And so you definitely want to look out for that video. You should be able to see that here soon. So these potential relays, they allow us to put bigger capacitors in for starting purposes because they're not going to stay in that circuit. And so this is the normal resting spot. 2 and 1 are normally closed, but also 2 and 5 at your coil. So the moment I have coil voltage here, then I open, the moment I have coil voltage here, then I open here, and there is absolutely no way when that's open that start capacitor can be part of that circuit. It's just in parallel at that point doing nothing. It's just connected. So it's on standby for startup purposes only. In the event potential relay chatters, buzzes, makes a noise, replace it, because if that relay fails and that start capacitor stays in circuit, now it's one gigantic run capacitor. Because if you look at what I've done here, the way this is, that's a very big capacitor. Now we're going to take a capacitor here in a second, and we're actually going to add it and figure out how to wire that up on the diagram like we did at the table perspective. But the last thing you want is to ignore a potential relay that is failing, because you do not want this to stay in circuit for anything more than a second or less. That's too much energy, and you will damage that start winding if it stays in circuit. So I'm going to go ahead and clean this up, and we're going to wire this one more time using a couple of different capacitors. We're going to play with some numbers to give us a couple of examples. I'm going to erase all this because we're just going to do it all over again. It's not hard. Let me go ahead and make that eraser a little bit smaller so I don't have to rewrite everything. There we go. If I took and said that I needed to add 2 capacitors and still add my 5-to-1 start kit in combination, how would I do that? Well, first we got to come up with a value of what we need. So if we said that this condenser fan motor needed to be a 5 microfarad and this compressor, say it needed to be a 50 microfarad, right? Then, and say that the capacitors that we had on our truck, if we're changing that capacitor out because it's weak or just it's just shorted, it's open, then we had to use 2 capacitors to make that happen. How would we do that? So let's just, I'm going to give you 3 different examples, and so we don't lose track, we're going to write these examples out. We're going to say we need a spare post, all of our posts, and we're going to say a dual, so this will be a single here, all of our posts to make a single, and then actually that's not going to work out, so say we want a dual large, and then we want we'll say a single large. Okay. All right, so one example, and it's kind of like what we did at the table, we kind of did that, so we're just going to use different numbers. So say this capacitor here, straight out of the box was, say it was a 45 plus 5, and say this capacitor down here was a let's just say this was a 25 plus let's say it's a 25 plus 5. Okay. All right, so say this is what we had, and we had to get 50 plus 5. How would we do that? Very simply. So and as I do these, I'll go ahead and erase them, and we'll do whatever's left. First thing I'm going to do is I'm going to go ahead and do the easiest one. Let's go ahead and do a single large. I'll take this fan and this hermetic, I'm going to add them together. That immediately gives me 50. All right, so 45 plus 5 equals 50. Okay, so I can easily run that to my compressor. I still need a 5 microfarad for my fan. So in this situation, I'm not going to use my 25 side. I'm only going to use my 5 side. Okay. And so if we were to wire that up, I'm going to use red for my commons. I'm going to come out of here and I'm going to run over here, and then I'm going to come out of here. I can either come out of here and run it down to here, or I can come out of this and just kind of jump it out to here. It's the same thing. It's still L2, right? And so when I put that X there, this is my hermetic over here. I'm not going to use this post, okay? And so now I can take this single capacitor and give 50, and I can take this single capacitor and give this 5. So we're going to go ahead and wire this one up now. I'm going to go ahead and take one, use red. I'm going to go ahead and wire it up as it comes pre-wired. We know we have 5 to wire up, I have that to wire up, and let's see, we have 2 to wire up. We know 2 is going to come down here to my hermetic post. So we'll come over here, wire up to my hermetic, which is now 50 microfarads. That's going to come out, and it's going to land on my start winding. Okay. I'm going to come over here with purple. Since I'm talking about start, I'm going to come out of my fan side, and I'm going to run over here to start. Okay. While I still have, let me go ahead and switch that up. L2 that I'm messing with, because everything I've done is literally off of L2. So this is off of L2. All this is off of L2. So I'm gonna go ahead and finish up with L2. I'm gonna come out of here, and I'm gonna run over to my run winding, to my condenser fan motor. And I'm gonna come out of here, and I'm gonna run up to my run winding on my compressor motor. And so now everything for L2 is complete, with the exception of my start capacitor needs to land over here too. So I'm gonna come out of here, I'm gonna run it down, and I'm just gonna tie in here to this common. Now I can also come over here to my contactor, but it's kind of busy, so I'm gonna use that extra post over here. I could have done the same thing, and I could have ran it down to here, and that would have been fine too. All right, so everything for L2 is 100%. As you can see, L2 is extremely busy. So we're gonna come over here and go ahead and draw out L1. We know that L1 is gonna come over, it's gonna land on terminal 5. I'm gonna go ahead and land it real quick. We also know that L1's gotta feed my common on my condenser fan motor, and L1 has to feed, okay? I don't like how I did that. I'm gonna do that prettier. I'm gonna come down below all this, and when I get here, I'm gonna go and switch it over to another color, and I'm gonna land it. And so everything is 100%, and that's pretty easy. The stuff is not hard. So I have one single capacitor here, one dual capacitor, right? So the 45 plus 5, you might be looking at it like, oh my God, I got a 5, a 45, and I got a 25 and a 5. How do I do that? Okay, well, just calm down. Take the 25 plus 5. We don't need to use that for anything. It can't do nothing. Just use this for a small single capacitor. So I took a dual here that was 25 plus 5, and I made it a single 5 microfarad capacitor just by not hooking anything up to it. Okay? In theory, I still have 25 here, but I'm just not going to use it, right? Up here, I have taken a dual and I've made it a straight up single 50 microfarad capacitor by taking 45 and 5 and adding them together. So now I have 2 dual capacitors, and I was able to achieve this. So I have my spare post, I have my spare post that I was talking about. That would be my spare post. And over here, this would be my single large. So now we're going to go back and we're going to do a dual large. Kind of covered a lot in that one. That was pretty cool. We're going to do a dual large now. So let's go ahead and erase these values. Let's go ahead and draw this whole thing again. We'll go ahead and leave L1 and L2 over here. No reason to rewrite that. Fix my common. Here we go. And now we're going to say that, let's just say we needed 50 plus 5, and say our fan sides were 5, and our hermetic side, let's just say this was a 30 plus 5, and say over here this was a let's just see here. I want to do I know I'm going to do a +5 something. Make a dual large, then here, let's do it this way. We'll say this is a 20 +5, and what we're going to do up here is we're going to say that this is a 25 +5, and I know I'm using weird numbers. That's not the point. The point is learning how to add, which I know you know how to add. So we're talking about how to add capacitors. So how would I do that? Okay, well, if I take this first dual capacitor and I were to jump the fan and the hermetic side out, then this already makes 30. But I need a dual large. So this is now a single. It's just a 30, okay? That's all it is. So I'm gonna take this over here, this hermetic side, and I'm gonna go ahead and add in this hermetic here, which I know is 20. And so now what I've done is I've taken 30 and I've said 30 plus 20 equals 50, but it's a dual, so there's still a plus here. I have my plus over here, which is the 5, the fan side. So this is 50 plus 5. The moment I put commons in series, and I'm going to use red for my common, since I know that's going to come off of the same leg of power as my run winding, and I'm going to color code that red, so I'm color coding L2 red. So I'm going to say this common to this common will now make this one large dual capacitor, because the whole thing is now combined into one dual capacitor. That spare post is what makes it a dual. Tying them all together in series is what makes it a large dual. So we have now successfully achieved all 3 of these, and now we're going to go ahead and wire this up. And so 50 plus 5. All right, so we're going to go ahead and take one that's already pre-wired. We're going to wire that up. We know that this is going to come down to common by now. We should already have that memorized. We also know that we're going to take our highest value, and like we talked about at the other perspective, the highest value, this is 20 by itself, this is 25 by itself, and this is 5. The highest one value, it doesn't really matter, they're so close together, even though in conjunction they're all 50, would be here. So I'm going to come out of here and I'm going to run this over to start, but I don't want to confuse you on colors. So I was using red because it's all off of L2, at least it's going to trace back that way. So this is going to come over here to start, but since I'm on that color, I'm going to go ahead and take 2, and I'm going to come down and I'm going to wire it to the same post. So I'm using 4 prongs on that post. One to jump out the fan side to give me 30, one to jump out this other capacitor to give me another 20, one to tie into terminal 2 on a potential relay, and one to engage my start winding so it's in circuit. Okay, so a lot going on there. I could have done the same thing and I could have said I want to take 2 to here, and I want to come out of here to here. That's another way of doing that same thing. Okay, we're going to try it one other way. I can come over here to 2. I can tie this down to here. I can come out of basically here and run it to start, right? Problem with that is, what if I shorted out here or shorted out here and all I was left with is 5? This is going to be out of circuit the moment I come on. Now I got 5 microfarads on my start winding. I kind of want this thing to go out on thermal real quick, not try to run for a little bit because there's 5 microfarads on it. So I wouldn't do that. The way I want you to leave it is obviously with the right 1 capacitor, but in the event you got to get them running for right now, what we'll do is we'll take this 25 by itself, We'll run that over to the start winding, okay? And then we'll come over here from 2, and we're going to do the same thing. Let's go ahead and finish wiring this up. We got, okay, I'm already on the right color there. Actually, you know what? Let me take L2 and run it over here to run. And let me go ahead and feed power to my commons. So now all that's done. So now I'm done with L2. We're going to come out with L1. L1 is going to come over and run to our common on our condenser fan motor. L1 is going to come over and it's going to feed terminal 5 on our potential relay so we can get that second leg of power, that L2 plus that L1 for our coil to open the contacts. And then we're going to come out of L1 and we're going to have to energize the compressor. Let me switch the color so we can see it. There we go. So it's pretty busy. There's a lot going on there. And if this is busy, you can imagine trying to teach this at the air conditioner. Because even if I try to teach at an air conditioner, what's next? Oh, well, what's the Carrier look like? What's the Train look like? What's the Lennox look like? What's the Rheem look like? What's the Goodman? What's the Daikin and the Amana? And we're going to cover every brand there is. They can come out with 10 more that have the same parts in them. Forget all that. You should just know this stuff. If you're touching it, you should know it. If you're touching it, you don't know it, you need to be careful because you can get hurt. There's a lot of electricity here, and there's a lot of extra work you can create where you're going to have problems and people are not going to be happy with you. The start winding needs to be fed a leg of power, even though, and the leg we're talking about, as we say in theory, it's a third leg. It's actually L2, even though it's already getting L2. It's not getting it off of this capacitor. All right, so we're going to come over here and we're going to run that 5 all by itself on this large dual capacitor. We're going to run that over here to our start winding. Okay. All right. I can keep going on and on and on and on about this, but I'm just kind of being repetitive. And I value your time too, so rewind this as much as possible. We have one more video we're going to release talking about how to wire up a soft start. That soft start is going to be with a diagram up there. There's a lot that goes on to that. Do not compare hard starts and soft starts. There's absolutely no comparison in value. There's no comparison on how they're installed. There's no comparison on how they're wired up. There's not even a comparison in their name. One says hard, one says soft. All right, and there's no comparison in price. Huge difference in wholesale cost, huge difference in retail cost. One you might be able to put in 5 minutes. The other one, I guarantee you, you're not. One you probably definitely want to have in there if you have a home generator. And if they come out and say you need a soft start and you call your local AC company and they're trying to give you a hard start, it's not the same. They want the lowest end rush amps that's possible, and that soft start is going to do the job. All right, so we'll have a video just on that, and then we have a video comparing everything, just so you know, how do I compare these two in the event I want to buy one, talk about it with a customer, everything under the sun. All right, so I hope these videos help you out. Our job is to make this as easy as possible, not to confuse anybody, so we go over many different perspectives. We appreciate you. How you can best support this channel is to subscribe to it, like us. That supports the algorithm. Share this. It's your job to share knowledge. If it's hard for you to communicate this stuff, there's a share button. Just communicate that by sharing it with a buddy technician. Leave a comment. We read those comments. There's a lot of subjects that we're going to be covering. We want to put these subjects out in the proper order. We are not going to bounce around and talk about a start kit and then talk about how how to charge a system up. That's not how this is supposed to work. And there's not even a school out there that's even gonna do that. So if you've gone to an HVAC school, you're gonna understand that they're gonna talk chapter by chapter. We don't have a curriculum to pass out to you or show you what order we're gonna do things. We're also trying to, stay within the seasons too, and curriculums can't really do that because you have the control to watch these whenever you want. So we're going to take a subject and we're going to stretch it out so we best can understand that, and then we're going to get on to another subject. By the time we start really talking about some of the stuff that you're probably mostly interested in, like your shorts, electrical shorts, low voltage shorts, zone boards, airflow, superheat and subcool, we're going to cover all that stuff very extensively. Those are subjects that are going to be very, very long and stretched out. So we're trying to take other subjects right now and, release smaller sections of a series of videos like start kits. Let's just pick 3 that are most commonly used: the 5-to-1, the KS1, which is the same as the TO5, and the Super Boost. Those are the most common start kits on the market. Let's talk about those. Let's talk about a soft start, since there's a lot of action on those right now. There's a lot of confusion. And then let's just talk about how to wire that up in different perspectives and how to compare those together. So we're going to get off this subject and we're going to get on to the next subject. I'm not going to tell you what that subject is, so just stay tuned. We appreciate all your support. Stay safe. Thank you.